Hi guys, welcome to the third video on quadratics under Math SL. In this video we shall tackle questions that require you to analyze the vertex form of quadratic functions, and I shall solve the 5 questions on the screen in front of you, and I shall begin question 1 short. So question 1 came in paper 1, May 2002, question 13. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So you are given the equation y equals a times x minus h squared plus k. This is what we call vertex form. The graph has its vertex at P and passes through the point A with coordinates 1, 0. Write down the values of h and k. So the values of h and k are obtained from the vertex. We should know that for a form of equation similar to this one, this vertex form, the vertex of the parabola is given by h, k. Hence, since the vertex is negative 1, 2, h equals negative 1 and k equals 2. So let's say this again. We call the vertex of the parabola h, k. And if we are given the equation in this form, which is called vertex form, we simply find h and k from the x and y coordinates of the vertex. And bear in mind that there has to be a negative sign here and a positive sign there. So this is the standard form of vertex form. This is the typical vertex form. So all we have to do is find the coordinates of the vertex. Hence, h equals negative 1 and k equals 2. This is why this is a write down question. Write down means there are no calculations involved. You simply find the values by observation. So in order to find the value of a, I use the last piece of information I was given, which is that 1, 0 belongs to this graph. There it is. Hence, when x equals 1, y equals 0. So I just need to plug in 0 for x and 1 for y and find the answer. So this is what I've done right there. Instead of y, I've plugged in 0. A is my unknown. Instead of x, I've plugged in 1. And bear in mind, of course, that I have replaced the h and the k in the standard vertex form with negative 1 and 2. So x minus negative 1 gave me x plus 1. And of course k equals 2. So I've just placed 2 instead of k right there. So all that remains for me to do using the gold equation is just to plug 1 for x and 0 for y. Hence, this is the equation I obtain. If I simplify, I get 0 equals 4a plus 2. Hence, 4a equals negative 2 and a equals negative half. So take a minute to write the answer down if you will. And don't worry if you did not get this problem. We shall solve 4 more problems similar to this one. I shall now begin question 2 shortly. So question 2 came in paper 1, November 2006, question number 6. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So we are given the graph of a function y equals d times x minus m squared plus p, and we are given the x-intercepts 1 and 5, or 1, 0 and 5, 0. And we are given that the vertex lies at point m, 2. We are required to find m and p for question A. So we should know from previous videos that the vertex exists halfway between the x-intercepts. So the vertex exists on this vertical line in red right there. And we should know that the x-coordinate of the vertex has to lie at equal distances from the 1 and the 5. So the green distance right there, this green line, has to equal this pink line right there. because this is a symmetric parabola. Any parabola has to be symmetric, so the line down the middle has to cut it into two equal parts. Hence, we should know that the vertex has an x-coordinate exactly midway between 1 and 5. Mentally, you can figure out that this x-coordinate is 3. If you want a more systematic way, you can just get the average of the x-intercepts. So 1 plus 5 over 2, which is 3. Hence, the x-coordinate of the vertex is 3, the average of the x-intercepts. Next, we want to find the value of p. So, of course, we should know from the vertex form that the vertex exists at m, p, because this is the standard way of writing the equation in vertex form. So the vertex exists at m, p, which is m, 2, hence p has to equal 2. So the question B requires us to find D, and all we need to do in order to find D is substitute one of the points into the equation. So what I'm going to do is I'm going to rewrite this equation with my now deduced variables. So instead of m and p, I'm going to write 3 and 2 because I've already found m to be equal to 3 and p to be equal to 2. So I'm just going to put 3 here and 2 there, getting this equation in gold. Next, I'm going to substitute one of the points into the equation. I know that point 1, 0 exists. So what I'm going to do is I'm going to plug 1 for x and 0 for y and try to find d. This is what I've done. So 0 equals d times 1 minus 3 squared plus 2. Hence 0 equals d times negative 2 squared plus 2, and I solved the equation, obtaining a value of negative half for d. So take a minute to copy the answer down if you will, and I shall begin the next question shortly. So question 3 came in paper 1, November 2011, question number 1. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So we are told that f is a quadratic function with this graph shown right there. We are told that the vertex is at p 4, 2 and that the y-intercept is 0, 6. Of course, we could have deduced this piece of information from the graph. In A, we are required to write down the equation of the axis of symmetry. We should know that the axis of symmetry passes down the middle of the parabola. And since it is a vertical line, it has to have an equation of x equals something. And in order to deduce what this thing is, x equals what, we should look at the x-coordinate of the vertex. We know that the line passes through the vertex, which has an x-coordinate of 4. Hence, any point on this line has to have an x-coordinate of 4. So the equation of this line is x equals 4. Again, the axis of symmetry passes through the vertex, which has x-coordinate of 4. Hence, the equation of the line is x equals 4. So there you have the answer to A. You are next told that the function can be written in the form a times x minus h all squared plus k. This is the standard way of writing a function in vertex form. And we know that the vertex of this function is given by h, k. So since it has a vertex of h, k, we equate this to the actual vertex we have in the drawing. So h, k is 4, 2. Hence h equals 4 and k equals 2. It is as simple as that. Finally, we want to find the value of A. So we use the piece of information that we have not used so far, which is that the point 0, 6 exists on this graph of the function. So I shall plug 0 for x and 6 for y, obtaining this equation in blue right there, and this simplifies to this green equation right there. Hence 4 equals 16a and a equals 1 over 4. So the value of a is 1 over 4. So take a minute to copy the answer down if you will, and I shall begin the next question shortly. So the fourth question that we shall tackle came in paper 1, May 2004, times on 2, question 5. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So you are told that the diagram shows part of the graph of a quadratic function f of x equals x squared plus bx plus c, which intersects the x-axis at x equals 2 and x equals 3. Find the value of b and of c. So we are given the x-intercepts of the parabola. And we should know that if the x-intercepts are 2 and 3, then the factors of the equation are x minus 2 and x minus 3. Hence, the equation is x minus 2 times x minus 3, which is also expressed as x squared minus 2x minus 3x plus 6, or just x squared minus 5x plus 6. And now what we need to do is we need to compare the purple equation to the equation given in the question. So the equation is x squared plus bx plus c, and ours is x squared minus 5x plus 6. So we compare the value next to the x. So b here is equal to negative 5 in our equation. Hence b is equal to negative 5. And c in the question is equal to 6 in our equation. Hence c equals 6. Next, we are told that the diagram shows part of the graph of another quadratic function g. This function can be written in the form a times x minus h all squared plus 3. So this is what we call the vertex form of expressing a quadratic function. The vertex is at 2, 3 and the y-intercept is 5. Find the value of h, or rather write down the value of h because there are no calculations involved. You simply observe that in vertex form we should know that the vertex is h, 3. So h, 3 is given as 2, 3. Hence h has to equal 2. Again, from the vertex form of the equation, we should know that the vertex lies at point h, k, where k is 3 in this problem. So since the vertex lies at h, 3, we should know that h has to equal 2, because they told us that the vertex lies at 2, 3. So 2, 3 is the same as h, 3, hence h has to equal 2. In order to find the value of a, I need to plug another point into the equation. So knowing that the equation now is expressed as a times x minus 2 squared plus 3, I've substituted the h with 2. I can simply substitute the point 0, 5 into the equation. 0, 5 is the point that they gave us in the question, both from the graph and right there. We know that the y-intercept is 5, so we have point 0, 5 that lies on our parabola. Hence, I'm going to substitute x with 0 and y with 5. So 5 here and 0 right there. So we get 5 equals a times 0 minus 2 squared plus 3. So 5 equals 4a plus 3. Hence a equals half. So take a minute to copy the answer down if you will, and I shall begin the fifth and final question shortly. So the fifth question came in paper 1, May 2016, time zone 2, question 1. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So you are given that the following diagram shows the graph of f. The vertex is at 3, -1 and the x-intercepts are at 2 and 4. Given that the function can be expressed in vertex form as follows, find the values of h and k. And we know that in vertex form, the vertex exists at h, k. If the function looks like this, as an equation, then the vertex of the function or the parabola lies at point h, k. So since the vertex lies at 3, -1, hence h is 3 and k is -1. So there is your answer to A. You are told that the function can also be written in the form x minus a times x minus b, which we call factored form. These are the factors of the function. And from previous videos, we know that if the x-intercepts are 2 and 4, then the factors are x minus 2 and x minus 4. Hence, a is 2 and b is 4. In question C, we are required to find the y-intercept, which is this point right there, the y value of this point right there, knowing of course that the x value is 0. So we simply plug 0 instead of x into this equation right there, getting 0 minus 2 times 0 minus 4, which is -2 times -4, which is 8. Hence the y-intercept lies at 8. So take a minute to copy the answer down if you will. This concludes the 5th question and the video. I hope you have found this useful.